Hello everyone, I am Anuradha Haith. Today I am going to teach basics of probability. Now, what is the meaning of probability? Probability means possibility or chances. In our life, we are not sure about many things like tomorrow there will be rain or not. There is a cricket match, so between two countries. So who is going to win, who is going to lose, or there is a draw in the match. So we are not sure about it. So whenever we are not sure about it, the question comes, what is the possibility or chances of happening this or the other? Probability gives us the mathematical measure of possibility or chances. So we can write that the meaning of the word probability, it is possibility or chances. Okay, or chances. For example, we are throwing a dice. Okay, so if I throw a dice, we are not sure that which is the point we are getting. We can get 1, 2, 3, 4, 5, or 6. We throw a coin, we can get head or tail. So now to define what is the mathematical definition of the probability, before that we should know some more other definitions. Okay, the first definition is of sample space. We denote it by capital S. Now, what is sample space? Whenever we are performing a random experiment, whatever possible total outcomes are there, like example, we are throwing a dice. So what are the points we are getting? So we will write S equal to 1, 2, 3, 4, 5, 6. So which includes all the points. That is called the sample space. We throw a coin. So what will be the sample space? Head and tail. We throw two coins. So if I throw two coins, what will be the sample space? We might get two head. We might get one head, one tail, or we might get two tails, right? So this way, if I toss three coins or we pick a card from a pack of cards, there is a bag with containing different color of balls. We are picking up one ball. So this all, whatever the total possibilities are there, that is called the sample space. Now, after defining sample space, we come to event. Now, what is event? Event is a part of the sample space, right? So if I take the subset, suppose this is the sample space and we define a subset in between the sample space, that is called event. For example, here, if I throw a dice, S becomes 1, 2, 3, 4, 5, 6. Now, we can define different events here, like the odd numbers. So if I take odd numbers, we are going to write 1, 3, 5. We can define the even numbers. So it will be 2, 4, 6. We can define the multiple of 3. So multiple of 3 will be 3 and 6. So these are called events. The third point, mutually exclusive event. So what is it? Mutually exclusive events. So let us take two events are there. Okay. And if it is that the occurrence of one event restricts the occurrence of the other event, then these two are called mutually exclusive event. For example, A is the odd number here, and if I define C even number, 2, 4, 6, right? So if I take A intersection C, there is no point common in between A and C. So we will denote it by phi, that is the null set or the empty set. Then these two events, A and C, are called mutually exclusive events. But if I take A and B here, so if I take the intersection between A and B, we can see there is a common point 3. So they are not mutually exclusive events. So mutually exclusive events, basically that one will happen and the other will not happen. So next, let me define exhaustive events. So just now the example I gave, we are throwing a dice, we are getting S equal to 1, 2, 3, 4, 5, 6. Now A is equal to odd number, C equal to even number. So if I take, instead of intersection, if I take union, A union C. So what I get back all the points. That is nothing but the sample space. If there are two events or more than two events, when we take the union of the events and we get the sample space, which includes all the points, then those events are called exhaustive events. And mathematically, we define like A union. The two events we are taking, 2 or 3 events, we are taking the union and we get the sample space. Now, combining all the definition of this sample space, mutually exclusive, exhaustive, some more things are there like equally likely. where we are selecting any point randomly. So every point has the same probability of being selected. They are called equally likely outcomes. So suppose the same example, if I take, I'm throwing a dice. So S equal to, that's the sample space. How many points are there in the sample space? 6. So I will write N equal to 6. Now suppose the question is that what is the probability of getting even number? I have defined even number at C here. I will write probability of C and the formula will be M by N. What is M? I will count how many points are there in between the event C. So I can get 3 points here and N equal to 6. So 3 by 6 will be, we will simplify and get the answer. So what is the definition of probability mathematically? So we will call it mathematical definition of probability. Okay. If there is a sample space which belongs in outcomes, the outcomes are mutually exclusive, exhaustive, equally likely. And we define an event A between the sample space. And suppose M points are favorable to the event A. Then the mathematical definition of probability is that probability of the event is equal to M by N. This is called the mathematical definition of probability. This is the first definition of probability. There are some more definitions of probability. Now let us take some simple examples. The first example I have written here, 2 unbiased dice are thrown, right? 2 dice are there, 2 unbiased dice are there. We are throwing the dice. Find the probability that both the dice show same number. First dice shows 6 and the total number of the dice is 8. So first we are going to define the sample space. So when we are throwing 2 dice, what are the possible points we are getting? We are getting 1, 1, 1, 2, 1, 4, 1, 5, 1, 6, like that 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Next, 3, 4, 3, 5, 3, 6. Then I get 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. Then 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. We are not going to read it 11, 12 like that. We are going to tell 1, 1, 1, 2. The first column is the number of the first dice and the second column is the number of the second dice. So how many points are there? If you count, there are 36 numbers. So N equal to 36. The points in the sample space is denoted by N, which is equal to 36 here. Now let us take the first question, number 1. Let me define this is event A, this is event B, and this is event C. So probability of A, we are writing the formula M by N. Both the dice show same number. So what will we get it? That is 1, 1, this one, then 2, 2, then 3, 3, 4, 4, 5, 5, 6, 6. So these are the 6 points where both the dice are showing same number. So how many are there? 6. So 6 by 36, you have to simplify. 1 by 6 is the answer of the first question. Next is first dice shows 6. The first dice should show 6 number. So where we are getting that? First dice means the first column. So we are going to the last one. First dice is showing the 6 number. We are getting 1, 2, 3, 4, 5, 6. So how many are there? Again, we are getting here probability of B. We will get here 6 by 36. So 1 by 6. Okay. So now next is what? The total number. The total number of the dice is 8. If you add the total number, it should be equal to 8. So let me see. So we are starting from the first 1 plus 1, not 8. Go to the last one, 1 plus 6, not 8. So again, go here, second column mein jao, and then you go to the last value. Are you getting 2 plus 6 equal to 8? So this is satisfying my condition. Then you go to the next column, 3 plus 5 equal to 8, 4 plus 4 equal to 8, 5 plus 3, and 6 plus 2. So how many are there? 1, 2, 3, 4, 5. 5 points are satisfying the condition. So what will be the probability? The probability of the third case will be 5 by 36. You can keep the answer as 5 by 36 or you can simplify to the decimal. Come to the next problem. What is it? 2 unbiased coins are tossed simultaneously. Find the probability of getting at least one tail, majority of heads. Okay. So if you are tossing 2 coins, what will be my sample space? So head, 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 tail, head, and tail. So how many points are there? 4 points are there. Okay. So first question, probability of at least one tail. Let me denote it by A and this is B. So probability of A. At least one tail means what? Minimum one tail is there. Either one tail or more than one tail. So what are the case we are getting? This one, and this one. At least one tail here, two tails here. So how many cases are there? 3 upon 4. So this is the answer of the first question. Second question, majority of heads. The meaning of the word majority of heads is number of heads will be more than number of tails. So we are not getting here because head and tail are same, and here no head is there. So what is the case here? Only one case, head and head. So what will be my answer? 1 by 4. So first answer is 3 by 4 and the second answer is 1 by 4. Now come to the third question. What is the question? A bag contains 10 white and 11 black balls. So total how many balls are there? There are 21 balls. I'm not writing here 21 balls. You may write it, but it is just no need of writing. We will write in this way, n equal to total number of cases. When too many cases are there, we can write it in this way also. So how many balls are there? 21. 2 balls are drawn simultaneously from the bag. If you are selecting 2 balls from a bag from 21, so I hope it is that you know everyone, it is 21 C2. From 21, we are selecting 2. So what is it? 21 factorial, 2 factorial, 21 minus 2 is 19 factorial. So what I get here, if I simplify, I'll get 21 into 20 divided by 2 and in upper 19 factorial and 19 factorial. So 19 factorial get cancelled. 10 2s are 20. So what is my answer? 210. So 210 is the total number of cases. Fine. Now let me see what is the question given here. Find the probability of getting both white balls. Let me denote it by A. This is B and this is C. Both white balls. Okay. So both white balls. 2 balls I'm selecting. How many white balls are there? 10 white balls are there. So the first question, it will be probability of A. We are going to write the formula. So 10 white balls, from 10 we are selecting 2. This is the value 10 C2 divided by 210. You can simplify this 10 C2 using the factorial formula, combination formula, and so you will get the final answer. Second question, probability of B. So what is probability of B? 1 white and 1 black ball. So 1 white and 1 black ball. From white, 10 white, you are selecting 1 white, and from 11 black, you are selecting 1 black. So it will be 10 C1 for and in probability we use multiplication, right? So it will be 10 C1 into 10 C1 into 11 C1 divided by 210. So anything combination 1, if you split it, you will check that 10 C1 will be 10, 11 C1 will be 11 divided by 210. And you can simplify like 0, 0 cancel. This is 11 by 21 is the answer of the second case. Now the third one, the last one, probability of C. So let's see what is the question. No white ball. Obviously, if no white ball, you are selecting 2 balls. If no ball is white, what will be the color of the balls? Both will be black. So basically, this is the question that you are selecting 2 black balls, right? So how many black balls are there? 11. So what is the case here? 11 C2 divided by 210. So if you simplify 11 C2, what you will get? 11 factorial, 2 factorial, 11 minus 2 is 9 factorial divided by 210. So what I get here? 11 factorial, you will write here 11 into 10, 11 into 10 into 9 factorial, 9 factorial, 9 factorial get cancelled. 11 into 10 by 2. So you will get here 11 into 10 by 2, 10 and 2 cancels. And let me write here 11 into 10 by 2 divided by 210. So 10 and 2 cancels, you get 5, 5, 11, 55 divided by 210. You can more simplify it by cancelling 5. You can keep the answer in fraction or you can keep the answer in decimal. So these are some basic problems where we are using mathematical definition of probability, and the formula is probability of the event equal to m by n. Thank you.